And we are live. All right. Welcome, everybody. Welcome back to Turbonomic Labs. My name is Eric Wright, and I am going to be your host on this fine Thursday. Turbonomic Labs is part of our team's uh, new methods in which we can really share good practitioner level content. So if you're looking at using technology and you really want to dig in and see it in action, this is a great chance. What I've found is, in speaking with more and more folks in the field, in the tech community, that these types of opportunities to do demos and be interactive are really kind of a great boost for us. So speaking of interactive, this is actually a completely interactive opportunity. If you've got any questions along the way, we are now broadcasting over a variety of different streams. So we're going out over YouTube, we're going out over Periscope under the Turbonomic handle. We're going on LinkedIn Live. So if you're seeing that, scroll by in your stream, hang on there and you can watch. You can drop in comments and they'll show up for me right in the screen. Always good to know when folks are watching. So give us a shout out, give us a thumbs up. And as well, just to give you a layout. So as you know, Turbonomic Labs, if you've been watching us before, we have featured Turbo Tuesdays. Goodness gracious, that's hard to say. It's a lot of T's. Turbonomic Tuesdays are focused on very specific sort of Turbonomic, Park My Cloud, Sev1, some of the new capabilities and some exciting new features that are coming very rapidly out of the Turbonomic engineering camp. So you're going to want to stay tuned and really stay tight with the Turbonomic blog and watch for some upcoming news. Wink, wink. Right, we got some really cool stuff coming. And then on Thursdays, we share I call it sort of open tech Thursdays. This is our office hours sessions. And it doesn't necessarily have to be open source, but we feature a lot of open source content. We've done stuff with OpenShift. We've done stuff with containers. We've talked about AWS. So in fact, that's going to be the subject of today. What I wanted to talk about is stuff that matters to you. And I get a lot of requests from folks out that are in the community saying, hey, it'd be great if we could get a real true walkthrough of how you do certain things. So we've done our infrastructure as code sessions with Terraform and VMware. So today we're going to dig in a little bit more on the cloud side. Now, if you're a fan of AWS, which is most likely the case, you're going to be some kind of a user. One of the most fundamental things about AWS is the VPC. It's not necessarily the service that started off AWS. In fact, that was really S3 and the SQS, I think, were sort of the original ones, the queuing services and storage. And then they brought in EC2. However, one of the foundational components of your AWS infrastructure will be your VPC, or the virtual private cloud. And we're going to walk through literally a ground up what it takes to be a wizard, right? So if you go and you launch the wizard, we'll go through what that means, what the different settings are, and then we're actually going to walk through all of the different VPC settings interactively so you can see what makes up the AWS VPC and stuff that you watch out for. This is great for folks that are doing their AWS systems architect associate level exam. In fact, it's one of the study sessions that's highly recommended because this will be a strong part of what you need to cover, as well as S3 storage, EC2 basics, but definitely VPC is one of the core features that you need to understand when you're taking your AWS essay. And so we're going to try and prep you in this hour, how to be ready for that portion of your exam. And most importantly, this is a chance for you to kind of explore where things are happening in your AWS environment and stuff that you're going to watch out for. So with that, let's jump right in and actually get started with setting up your AWS VPC. Now, the neat thing about the VPC is it is a virtual private cloud. And what that means is that you are running on shared infrastructure, but you need to have a logical construct that's wrapped around your AWS resources. So you can have a variety of different resources that are in AWS that can run inside different VPCs. You in your customer environment, when you create your first, account, every region you have has a default VPC. So you don't even have to do anything and you're in a default VPC. However, that's generally not a good idea to launch a lot of things in your default VPC because effectively they're all just sitting beside each other. You don't have control necessarily over subnets and networking. So default is probably not the way you want to go as you look at actually building and adopting in the cloud. And you can see in the VPC configuration. Now, number one, I should point out that the console will change. So if you're watching this on replay, literally over days and weeks and months, you will see some big differences in what the look and feel is. However, the core components and the fundamentals are still pretty strong. And you'll find that the exam certification is based on stuff that's not like the latest and greatest in the UI. It's really on the core fundamentals. As you get into the professional level certification, they're probably a little bit more current with some stuff, so you have to watch out a little bit more tightly. But you can actually just click out, you can launch the VPC documentation. And in fact, all of the documentation for AWS is where the exam content comes from. So I've gotten my SA, I've got my DevOps. Everything you do is about really stuff that you can find publicly. You don't need to take special courses. You just need to know, what are the components you need to cover. So if you actually walk through the user guide, you can get all that you're going to need for VPC. And the beauty part about VPC is a VPC is free. It's literally just a set of ACLs and rules. The only thing that you have to get charged for in a VPC is your gateway. And that's the communication boundary where it actually is able to communicate either with the internet or with a peering connection in another VPC. So when you see the default screen, it actually shows the cool thing as you see more and more, you can actually show by region, which is neat. This is one of the complaints a lot of folks had around AWS is that I have to go region by region. So now you can actually see that there's, resources across region. And as I mentioned, so there's one VPC in every single region. That's the default VPC. It doesn't have a name. It's just called the default. That's it. But if you see a higher number there, 3, 4, etc., that means that we have specific custom VPCs that have been created. You can actually go through, take a look at the active VPCs. In this case, I'm in East 2 in Ohio. So shout out to the folks at WKRP. I like to not do everything in US East 1, which is where a lot of us end up. You have your subnets, which are going to be your logical subnets and for your IP networking. And these are, again, we've got the defaults, which are available, as well as your public and private subnets that are specifically allocated to new VPCs that you create. The important thing, subnets are only good if they're routing to each other. So this is your routing tables. Again, there's going to be certain things where you see the default VPC and everything in here is clickable. So it's very easy to kind of get lost and drill around. You're going to want to spend a lot of time in the UI and becoming familiar, because by doing that, you're going to understand, knowing the CLI side is super handy as well. And we'll dig in on a separate session, but I didn't want to cram too much in one blast here. So make sure that you're very comfortable with kind of every option that's in that. You've got your internet gateway, and you'll see some stuff like there. You see it says new when new things become available. So this is gateways in which that they're able to communicate with other internet resources and inbound. We've got egress only gateways. It used to be one setting, and you would define it by the rule set and by the outbound access and the egress access. So when you configured your resources inside your VPC, by default, it would have access to the internet. However, it does not have inbound access. There are some good defaults that are set up. So if you want egress only gateways, you can have it so that There's only one-way communication. DHCP option sets. This is handy if you're doing internal DHCP for your resources and you want to assign specific IPs. I'm a big fan of doing this for a variety of reasons. As I do more stuff with stuff like digital rebar, which it comes out of the rack end camp. So again, shout out to Rob Hirschfeld if you haven't followed him. He's at Zehicle, Z or Z, sorry, depending on what country, Zehicle. So it's good to follow Rob. He's doing a ton of stuff in the cloud around bare metal and up automation. So he's a fantastic resource to follow. Elastic IPs. So you have two kinds of IP addresses, as you may know. You have an IP address where you can actually assign public IP addresses as you spawn resources like EC2 and different things inside your VPC. Or the challenge with that is that every time you spawn a new instance, it gets a random IP address. If you allocate an elastic IP address, then you have a consistently addressable IP address, and you can just attach it to resources. And now, again, you have to be careful because as you launch an EC2 instance, for an example, it will ask you, do you want to launch it in a VPC or in the default VPC? And your elastic IP addresses will be allocated within the VPC. So like I said, if you go by the pool, you have the opportunity to, where you can allocate those in and out of VPCs. You've got your prefix list. So this is a custom prefix that's attached. You're probably not going to see this on your essay exam, so you don't have to dig too hard into that. Understanding endpoints. So this is where you can create an endpoint connection to other AWS services. This is especially popular for S3 or other marketplace services. Again, the most common use case that I find is you create an S3 endpoint so that you can have easier peer communications between resources. Endpoint services will ultimately come up when you create an endpoint. It'll be good to read through the documentation so you're clear on what the functional reason is and the use case for these. Your NAT gateway. So this is the ability to, NAT all of your traffic to the outside. If you're into networking, this will be very familiar. If you're not familiar with networking, we're gonna walk through a bunch of it today, but we actually should do a deep dive. And if you want, drop in a comment if you want to see a deep dive on networking. We're probably going to dig in on that. It is a fundamental part of your design and configuration, as we'll see when we do our first launch. Peering connections. You have the ability to peer your VPCs with each other so that they can go and have a direct transitive path from one endpoint to another through, regardless of where they are. Otherwise, you're effectively going out and back in through an egress. So you can actually create peering connections. This is also handy for creating adjacent peer connections with other VPCs that aren't even yours. So there's a few different use cases you'll run there. And then on the security side, this is the important bits. Two things you're going to have is you have the ability to block access first by route. So just classic where you're doing layer 3 types of routing. And then you can move further up. So you now have the ability to do network ACLs. And then you have security groups, which security groups effectively are a good way in which that you're saying certain traffic is allowed in, certain traffic is allowed out by source, by destination. Network ACLs are a little bit more tight. So you're going to find that it's sort of the layer, the OSI layer that they're working at. So you can assign it to your VPC, set your ACL, echo 20. And then from there, you can create your specific rule. So we'll walk through that in a second. Gateways, again, the gateways are, as they sound, right, a path in which you can reach from one end to the other. So you have your customer gateways where you're actually potentially connecting to internal or external environments. You have VPN gateways, so you can set up a software or hardware VPN in order to continuously communicate. This is especially popular if you've got a data center environment and you want to do secure communications. You set up a VPN. If you don't have a direct connect, which is the alternative method, VPNs are very popular because then you can set them up from multiple locations. Site to site, same story. Client VPN endpoints, so you can set a soft client or a hard client for VPN if you're using stuff like pfSense and a few different things. OpenVPN is a very popular one. So you're going to have to understand kind of like what the different gateway types are for your exam. And then we get into the traffic mirroring, this is a deeper dive we're not going to touch on today. But again, you're going to realize very quickly the security and networking, which is really what VPC is. VPC is a security boundary and a networking boundary to resources within AWS. So even though you're on shared infrastructure, you're already blocked off by default. However, you may need to crack open the firewall a bit, so to speak, in that you can allow inbound and outbound access for certain resources. So be careful, because there's plenty of opportunities to make a mistake of putting a publicly accessible resource in your VPC. And worse than it being accessible and vulnerable directly, it then becomes the jump spot for other resources in your VPC. Because remember, once you're in your VPC, you now have intra VPC access. Okay, so we've kind of done a walkthrough of the different things that you've got in here. So we go back to our dashboard. We've got a bunch of VPCs, and let's just go through. The reason why I said like you're a wizard, because we want to know, what does the wizard do, and how is it that we can differ from taking the wizard boundary and route to get there. So if you take the wizard, there are 4 configuration options. One is VPC with a single public subnet. This is pretty common and easy for most people when they're getting started, because you're going to have to understand how networking works and how certain services leverage networking. This is literally going to be, one public subnet in which you can host all of your resources, and it's not public in that it's fully open, but it has the potential to be fully open. There's no special routing required. It's automatic. It has internet access, and the internet, if given the right network ACL or security group, will then have also inbound access. The second option, which is the probably, I wouldn't say, I don't know percentages, but let's just say a large percentage of enterprise organizations and people that are getting further into their exploration of resources are using a VPC with public and private subnets. The reason why you want to do that is that you could have public-facing resources, but then back-end services that you don't want to ever have exposed to the public internet, nor is there a need for them. So let's just say you've got a front-end web server. You've got a 3-tiered application. Your front-end web server can be in the public subnet. You can have a scale-out group, et cetera, et cetera. But then your backend resources, you would never want your database to be exposed to the internet. There's no functional reason. So you can put it in a private subnet, and then your web server communicates through the network routes to the private subnet, and there's no way through transitive access to get to your database server. So there are still ways to accidentally expose those resources, but by default, you have an option now to protect it. When you're designing your network, there's a lot to consider here. Then, of course, there's the 2 accesses, which are for setting up VPNs. So you can have either a hardware VPN access, in this case, where you're going to have some kind of a connection to your corporate data center or your personal cloud connection. And that's with a private and public. And then there's also private only. The reason why you would do private only is maybe you want to leverage extra services that are out in AWS, like you want to use, stuff like DynamoDB, you want to use the machine learning, you want to use SageMaker, you want to use all these really fantastic services, of which there are hundreds. But you need to make sure that there's no way that anybody but your data center has access to those resources. And this is what the use case would be. So let's do a quick one. Let's do this walkthrough. We're setting a single with a public IP address. So by default, it uses a 10 network. There's really I don't want to go deep into the network design portion here, but you need to understand general understanding of networking. You can choose whether you want IPv6 or not. It's something that you think hard. If you're using IPv6 or you plan to, you probably want to be planful about how you do this. So for right now, for most common use cases, you don't need IPv6. Sadly, we haven't gotten there yet. VPC name, so we'll call this pub 10. So you can see here that it's a /16 network, which means that these are going to be your available IP addresses. That is the minimum subnetting that you can do. The maximum, like the furthest subnet that you can create, I guess, the minimum, I guess, depends on how you look at it. So the maximum amount of IPs you can get is 65,000. And then, of course, if you change this, you'll find that it tells you through the magic of mathematics, and if you're into a subnet calculations, you know how that works. So you can set it up as a /20 network, and then it will tell you how many available IP addresses there are. However, this is your top level. So what you generally want to do is design it. So I'm going to choose it, and I'm calling it based on what I want to have access to. And you can see, so this is going to be my 1010 network. I'm going to call it pub 10. It's already told me there's an issue because it says, hey, your public range is not in the same range. And so the public subnet CIDR IPs that you get, by default, it goes to 24. So you can actually increase that. So if you wanted to have different networking resources, but let's go with the default. Your subnet name, public subnet 10. You can add service endpoints here. Enable DNS host names. By default, you can do this. There's probably security reasons to choose this or not choose this, because technically they could have a dictionary sort of approach and try to access public resources by DNS rather than just by IP. But by default, it's on. And at this moment, I don't know why I wouldn't need it. And you can choose default, which is shared or dedicated. You're going to most likely want default in this case. All right, so we do. So I'll zoom back out here. We create our VPC. It works some magic in the background. And there we go. All right. So now if I go to my VPCs, I see pub 10. Now when you go to take a look at your VPC now, there's a couple of different resources you see here. Of course, it is a new VPC ID, which is how a lot of your ACLs or your command lines for your CLI and your automation, you're going to need that IP that ID. Your route table, which is the default route table that's configured for it. And then, of course, you have the ability to create flow logs. It'll tell you what your different CIDR blocks are. You've got no IPv6 in this case, and the tags. And here I've only got a name tag, so I could add other things. Like I could say type equals public. I could say, owner Eric. There we go. Look at that. See, it tells me, it knows who I am. So that I know if I want to do other automation and other inventorying, you can do it by tagging, which is highly recommended. So the default, let's take a look at the default route table. So my route table here, it has, you have the option to show IPv6 or IPv4. Let's edit the routes. Okay, so local, pretty simple route table, right? Like it's literally just saying, hey, what are the route tables? We've got everything allowed to reach this destination. And that means that the routing is present. That doesn't account for subnet, your particular subnetting, your network ACLs, and of course your security groups. So your subnet associations, you have the option to assign a subnet here. So you can go in, you can set your subnet. You have edge opportunities. This today I don't think shows up in the architect associate one, but if you've got different edge gateways, etc. And then of course route propagation. This is more if you're using a peering connection and where it's going to, if you make changes here, where does that show up? Your subnets that we called it pub 10, so you can see under the VPC ID. If you actually take a look at that subnet, oops, sorry. See, that's what I mean. Everything's clickable. It can get confusing. Route tables. So where'd my subnets go? There we go. Let's go back to subnets. So now you have the option to either edit your route table. You can't edit the subnet. And this is important because once you create your subnet and you allocate resources and attach to it, you can't change it. So you can't go in and change the CIDR notation. You can't extend the subnet or increase the amount of IP addresses. So that's why it's important that we think about that at the onset. Okay, so that's the basic. We've got a very simple thing. By default, there's no access. It has outbound access so that every resource launched in my VPC will be able to reach the internet for things like security updates. And that's kind of the main reason. So you can go out to the internet and pull stuff back in, but by default, nothing can get in from the outside. Now, the next wizard that you get, let's do priv. We'll call this 30. And another note, in your VPCs and your subnets, you have to make sure you're careful because you can't have colliding IP addresses across VPCs. And you think to yourself, well, that's no big deal. I'm going to allocate myself a bunch of network addresses. This is where the challenge comes in, where maybe you merge with another company and they have a same IP scheme. So this is where the VPC peering and stuff like that will come into play. So we're going to call this 10.30. Oops. Oh my goodness. Sorry about that. I just realized. Where's that's what I wanted. Dashboard. It's my VPC wizard. So I'm going to choose public private. Priv 30. So I'm going to set my IP range is 30. Again, 65,000. That's the maximum you can get. You can't go. You can't subnet lower in the subnet mask than a /16. Now you're seeing a different here in that you now have things that are showing up. Again, it's going to complain as it should that I'm not in the right subnet. Okay, that'll stop complaining now. You've got different subnets you can create. This is where, look, talk to your network team. You know how challenging it'd be to make these decisions right now, but these are interesting decisions. You can move resources between subnets down the road. If they've got elastic IPs, you'll be safe, but there are changes that need to be made in order to relaunch into different subnets. So now I've got public subnet and a private subnet. And you'll see here that we've got this by default, it's a 0 and a /1. I do like to, name my subnets. We're going to call it pub 30 0, priv 31. And so that you can sort of quickly see based on the name tag, and you can set this to whatever you want. But again, it has to fall within the /16. And in this case here, you have to look for an elastic IP address to assign for a NAT gateway in order to access the rest of the earth, because you're setting a private subnet. And those private subnets have to have access. So you either can set an IP address, which I've got one available, or I can actually create a NAT gateway. If I use a NAT instance, it actually spins one up automatically. for me. But I'm going to actually use a gateway, and hopefully that's a live IP I can get. Same story. I'm going to use my DNS host names and hardware tenancy. So it's good to understand what that means, and I'll show you in a second. Ah, look at that. Here's another thing. There are limits on the number of VPCs that you can have in an account. And I have just hit the limit. So it's my belief, I think that it's 10 VPCs is the limit, or in this, oh, there we go. We've got 5. All righty. See, know that for your exam. You can get this limit raised, but in this case, you know, I want to be able to do some more stuff here. So I'm going to delete my other VPC that I created. This is why you practice a bunch of times and you'll find these limits the hard way. Okay, pub 10. Let me get rid of that one, because I had another one that I was doing as a test. If you have resources that are created inside your VPC, it will not allow you to delete them. As you can see here, when you actually go to delete, it tells you all of the different things that it has to delete along with it. The advantage is that when they're allocated through that wizard, it attaches everything inside it. It's pretty easy to do. Okay, so you've got a sense of where the public and private work together. Now let's actually create a VPC and see what these individual steps are when we're allocating them. So the first thing we're going to do, we're going to call it pub priv 77. Give it our IP range. So we're going to call it 1077.00/16. So I've got 65,000 IP addresses. I'm going to, again, say no IPv6 at the moment. I'm going to go with default tenancy. All right. It's that easy because you've literally done nothing except create the tag and the potential IP range that's going to be associated. And as I mentioned, let's try this just for fun here. Conflict. And 77.0.0/16. Right? It looks like it should error out, but it won't. However, if inside your range you have the same IP ranges in use, then it's going to throw an error. And the reason is because at the top level of the VPC, it's using the ID, not the name, not the IP range. So now we've created our VPC, just allowed to use it, set the base networking. Now we have to create a subnet. When you did this with the wizard, it made sense, right? It asked you, do you want a public or private subnet? Here's the quiz. How do you make it a public subnet or a private subnet when you go through and don't use the wizard? Pub 77. You choose the VPC that you're going to allocate. You can choose your availability zone. So you can say no preference, or you can assign it implicitly. Personally, I like to do this and assign it explicitly so that I know, and that is so that I can also use my IP naming schema in order to, like the addressing schema, to define where things end up. So this is 2A. So I'll call this usually 20 for A, 1 for B, you know, or you can say 21 for A. So I'm going to assign this subnet. I'm going to want it has to be within the 16. It can go down to 24. I could do 20. I can do whatever. So in this case, I'm just going to go with a class C range. That's 77. So it's in my space. And then, like I said, the 21 for me means that it's in 2A. Now, the only thing that will make this either private or public is the choice as to how you do your routing. So now when I go to I see that I've got pub 77. Let's bring this up a bit more. You've got the route table that's attached to it. You've got your network ACLs. So you now have the opportunity to make changes. You see with the route table that it's assigned to. You set the network ACL, and by default, this is your inbound and outbound. Oh, the magic of deny. That's a beautiful thing. So you're not accidentally, you've always got this deny rule. Flow of rules is the same. If you're used to firewalls, it's going to be evaluating them in order. So you always want to have a default deny towards the bottom, and this is going to be based on the rule. And so you've got your inbound and outbound. You can set the different ACLs that you want to attach to and the different subnets. You can tag it. And then also the opportunity where you can share other resources. Now, again, this is not going to show up. Good to understand. So do read the AWS docs. I'm not going to go at length to it here. We already have plenty that we're covering. So now what I'm able to do if I wanted to is to go through by the network ACL, and you can again expand this out. You're going to see the ID. Oops. That's weird. It doesn't let you expand that. It shows you the VPC that it's actually attached to. And so you can go and you could name this if you so desired. 77. And so let's say we wanted a pub 77. So we're going to have an assignment to my VPC. And now in your network ACL for your public 77, you have the option to set specific inbound rules that will either allow or deny. And you set this based on your rule number. So you can set it by default as, it automatically goes to custom TCP. You can set all your different, whether it's TCP, UDP, you can allow ping, ICMP, you can have custom protocols, you can have IPv4, IPv6. Remember that choice that you had to make? You can say all traffic and your source. So this is the important thing here. When you're setting this, you have to know the range. The range you're seeing here is everywhere. So you're saying that allow all traffic from all locations into this. So you can imagine that's a fairly bad idea. We're not going to do that. So let's just say we're going to limit that to, let's start with ICMP. Like not even I would be careful. Even ICMP is unless it's necessary, you should not enable it. So you can actually set the different ranges as well. Once you select a protocol, you can now go in and let's even go, we'll pick a specific one. Let's say HTTP is a great example. So we have HTTP, the port range is automatic. It's port 80, not a lot of range. SSH, it's going to be on port 22, right? They'll seem familiar. You can say all ICMP, and that's all. So that you can see if you specifically set your custom TCP, you can actually set your range. So I could say from 4,000, to 8,000 or whatever it's going to be. Oops. And so all you do is you define here. So I'm going to say 4,000 to 4,400. So anything coming in on those particular ports can be set. And the routing inside will define whether it's public or private. You've set your gateway before in the wizard. So the same thing will happen here is where I've got gateways that are already created and attached. So I'm going to say my 77 gateway. Now, what I want to be able to do is, I'm going to have to choose this, and that particular gateway then ultimately can be attached to my VPC. And understanding these steps that are happening behind the scenes in the wizard is important, because now I'm going to select a VPC, and I want it my priv 77. The cool thing is it actually tells you the CLI command for this, which is pretty awesome. So I'm going to attach my internet gateway. You have the option again, as I mentioned, to create an egress only gateway, which we don't have in this case, nor do we need. Elastic IP addresses, we've already got these created and allocated. And now what'll end up happening is these rules have been created. So we've got a public subnet, a private subnet, basic routing, a network ACL to allow a specific subset of ports into the range. And then the last piece that we'll touch on real quick before I actually launch an EC2 instance is your security group. So your security group, we'll call it 77 default. Default to allow SSH and HTTPS. You choose your VPC. You set your inbound rule. Let's say SSH source. You can say, this is different than your network ACL. You needed to know the network range before. Now you're going to be able to say a couple of things. Number one is you can say custom. You can say anywhere, which is everywhere. You can also do this neat thing where it says my IP address. So it'll actually automatically detect your IP. But we don't want that. We want custom. So we're going to say, I've got a range it there, and you can see it's actually doing a type ahead. You can either set it by network range, or you can literally put it right down to a specific IP address. So you do a /32. So only one IP address is. You can add so you can actually create these rules, and we'll call it my IP. And then outbound rule by default, you're already good. And you can set your tags if you so desire. So now I've got my inbound rule to allow my IP address SSH access. And you're going to say, wait a second, Eric, you called it HTTP as well, HTTPS as well. So let's go in and add a rule. HTTP. Same thing. I'm going to choose my IP. And in fact, let's even go a bit further. Let's add HTTPS, because that actually might have been the rule I set. Okay. Now, why is this different than what we saw with the network ACL? So the network ACL is much more strict in that it's literally base level network. Security groups, the network ACL is everything within your network has to match the network ACL. The security group is anything you attach to the security group. So if I now go into my VPC and I want to say, oops, let's just pick one here. Beep. Oh, yeah. So I know where I am. I'm going to do an EC2. And I'm going to launch an instance. Let's pick my AMI. I'm looking. Okay, so here we go. So now what we have is you're going to choose the network. It chooses the subnet. And by choosing the network that it goes into, you're automatically allocating it to a VPC. Remember how we said that networking is actually what VPC is fundamentally about, and then security, of course, goes hand in hand with that. You can set the auto-signed public IP address. We talked about this before. So let's just say in this case, I want to disable it because I only want to use elastic IPs. I'm not going to talk about placement groups, no directories right now. There's no IAM role I'm going to attach to it at the moment. So we've got same thing. You're going to choose shared or dedicated. If I chose dedicated, it would be angry at me because my VPC doesn't match up, so it would complain. So I'm going to say add storage, add tags. Always add some tag. There we go. Eric, there we go. And now you can select your security group. And in this case here, it's recognized that I'm going to get my default 7, review and launch. I choose my key pair. I acknowledge that I have the key. You'll find out the hard way if you don't. Okay. So now I'm launching my EC2 instance into my VPC. And that will be visible in the EC2 configuration. When it comes up, you can see it in the VPC ID, what subnet it's in, and then ultimately you'll get the IP address and it'll see the security group that it's applied to. And this is where the fun begins, because it's hard to keep track based on whether you're looking from the VPC inward or from the EC2 instances outward. This is the challenge of making sure you know where things are. But very simply, the fundamentals we just talked about are the things you're going to need to study. How do we create a new VPC through the wizard? What are the different options? And it will ask you those kinds of questions. It'll ask you, how do you create, a route? And it will give you a routing table. It'll give you a network ACL example. And it'll say, in this example, you need to be able to allow HTTPS access from all networks. What would the rule look like? It'll give you 4 examples or 6 examples. And this is, I'm saying this very generally. This is publicly available content. We have to be very careful because I am certified. I'm bound by the question itself that I can't share a specific question. So I'm just talking about generalizations, general type of content you're going to see. We want to make sure that we're respectful of the non-disclosures that we have as a certified professional. So you're going to understand what are the different subnetting, how do my security groups apply? So if I launch an EC2 instance into a network, but there's no network ACL to allow any inbound access, the security group isn't going to be meaningful at all. Network ACLs are interesting in that you have to have some, like the wizard's great because it takes care of it for you. If you're creating your own, you have to understand all the different ports and protocols you're going to allow. Security groups are what's curious about this, and you'll see this potentially come up in the exam, is they are stateful. So the moment that you make a change to it, it is automatically applied across the board. So as you allow access or deny access within your security group, it will be immediate. It's good to know. And so what you're doing is you've created your VPC, you create your subnets, you create your network ACLs. It has a default routing table, which it applies these ACLs into. You create your security groups in order to set a boundary for your instances and your other resources. You launch that instance in there. And once I've launched it into that VPC, it's stuck because it's bound to my network. It's bound to my ACLs. You can change security groups, but you can't move it in and out of VPCs. So it's good to know when you're thinking about launching. If you needed to move it between VPCs, you actually need to take a snapshot of it and then respawn it into a new VPC. So that is the sort of very quick soup to nuts on what a VPC is for you and how you can configure it yourself in order to be the wizard. So what we walked through was create the VPC, create the subnet, create a network ACL to allow some public access, allow it to one particular subnet, do not allow it to the second private subnet. The public and private can speak automatically because they're within the same range on the private side, and the route table is defaulted to allow. And you now have your own public-private without having gone through the wizard. I would say definitely read the docs. Shout out to the folks at AWS. They actually publish their docs and allow you to edit them as well. I think if they put them on GitHub. So if you do have suggestions and you want to see updates to the documentation, please do go ahead and submit a pull request or submit a change to it. And it's very, very cool that you can interact with them that way. We'll go into some of the CLI versions of those things in future. But for your essay exam, you do not need to know the CLI commands for everything. It's good to know the CLI in general for doing things like listing subnets, adding subnets, basic stuff. But practice. Because VPCs are free, the only thing you're paying for is the Elastic IP, which I think is it's like $1 or $2 or $4 a month. It's not significant. You can do this over and over again without incurring heavy duty costs. So you don't have to go to school in order to do it. You don't have to pay $2,000 for a course necessarily. And one last shout out I'll give, if you really want to get close to who's doing this well, I recommend the team at Pluralsight. I say that as I'm actually wearing a Pluralsight shirt. I happen to be a Pluralsight author for some different stuff. Also, A Cloud Guru is another good resource if you're looking to get certified. They're a fantastic set of folks that are doing really great content over there. I think Cloud Academy, Udemy, there's a few different places that are doing stuff. But that was AWS deep dive. We walked through the whole process. I do hope that's helpful. Well, actually, maybe I'll fire up a blog just to show you what the basics are that we just covered. And you can use that if you're looking to get certified. Of course, feel free to drop me a line there. That's me. I'm on Twitter. I'm at Disco Posse. And make sure you come on back for future Turbonomic Labs episodes. Thanks for watching. I hope you have a great day. And with that, good luck with your AWS certification. And I'm willing to help too as well. If you need a study buddy, then get connected, hook up with me on either Twitter or on LinkedIn. My DMs are open, and I have an open LinkedIn policy. Thanks very much. Have a great day.